Hey guys, Dr. Brown here with Kubo Math, and tonight we're going to look at a derivative of minus cotangent x, and it should equal cosecant squared x, because the integral, and we used this just the other day in a video, we used the integral of cosecant squared x dx was minus cotangent x. And I told you guys then, I said, well, along the concept of, well, where did they get that formula? Let's derive that. Let's take the derivative of negative cotangent x and see if we can get cosecant squared x. Okay, we're going to use the limit formula. The limit is h approaches 0 of f of x plus h minus f of x all over h. So let's get after it here. So, all right, so we would have minus cotangent x plus h minus the minus cotangent x. Well, since it's minus a minus, let's just put that as a positive, all over h. Well, we know cotangent, tangent is sine over cosine, so cotangent would be cosine over sine. So now we have the limit is h approaches 0 of minus cosine x plus h over sine x plus h plus, now cotangent x, which would be cosine x over sine x, all over h, and I'm just going to go ahead and put the h inside like that. Okay, now we can't add apples and oranges, so we need to get a common denominator. So I'm going to multiply this side by sine x over sine x. So I've just multiplied that times 1. I'm going to multiply this side by 1, but I'm going to let my 1 be sine x plus h over sine x plus h. Okay, what do we have here? Well, we know it's all over h sine x plus h. Alright, so I have sine x times a negative cosine x plus h. So I'll move the negative sign out to the outside. So sine x times cosine x plus h plus cosine x times sine x plus h. Alright, I've taken the liberty to look up sine x plus h and cosine x plus h before I started the video. So sine x plus h is sine x times cosine h plus cosine x times sine h. Now cosine x plus h is cosine x cosine h minus sine x sine h. So we're going to substitute those in for cosine x plus h and sine x plus h. Alright? See what we have here. We have a negative, well, it's all over h sine x plus h. I'm going to leave the x plus h here in the denominator and work with the numerator for the moment. Okay, minus sine x times cosine x plus h. So cosine x cosine h. Okay, and I'm going to still take that negative sine x and multiply now by the other side. So it's a negative sine x times negative sine x sine h, as you can see here. So this negative would become a positive. So it would be plus sine x times sine x. So sine x squared sine h. Okay, so that takes care of the cosine x plus h part of it. Now then, let's deal with this sine x plus h. So I have plus cosine x times sine x cosine h. plus, I still have this cosine x here, cosine x times this cosine x, so which would give me cosine x, cosine squared x times sine h. All over this. Now then, we have sine x, cosine x, cosine h. So I have these same three terms here. They may be in a different order, but I have them here. These are negative, those are positive. So these cancel each other. So they're gone. That leaves me with sine squared x sine h plus cosine square x sine h over h sine x sine x plus h. Okay, what to do now? All right, I have a sine h and a sine h. I can factor that out. So this is working out really good here. Sine h is factored out. And that leaves me with sine squared x plus cosine squared x. Whoa. Sine, that's a bad looking sine. Sine squared x plus cosine squared x over h sine h, or sine x, h sine x sine x plus h. So I have that limit as h approaches 0 of that. Okay, if I go through that limit, sine h over h, we've studied this before, that limit is 1. Sine squared x plus cosine squared x is also 1. So in the numerator, I have 1. Okay, this h was taken care of here, so it's gone. H approaches 0, so that one's gone. I end up with sine squared x. Oh, what is 1 over sine? Cosecant. So I have cosecant squared x, cosecant squared x plus, well, not plus c, we took the derivative. So you can see that the derivative of negative cotangent x, if we use the limit formula, we can work through that, and it does in fact come up with cosecant squared x. Okay, why are we doing this? Hey, we're trying to build a better tomorrow and do that through math. Buy a kid a book, okay? Get linked up with your local school and help those teachers. Get them some supplies and things that they need to help these kids. Okay, hopefully you enjoyed this. That's all for now, and we'll talk to you next time. Thanks.